Hey everybody, it's Mr. Carr again. Today we're going to be looking at 1 for day 2. Yesterday we covered, or last lesson we covered extrema. Now we're going to be looking at what's called average rates of change. Okay, so let's talk about what is an average rate of change. So the average rate of change between any 2 points on the graph of f is the slope of a line through those 2 points. Okay, so it doesn't matter which 2 points you pick; it's just kind of arbitrary. So when you pick them, the idea is this: if I have this is my curve f, okay, that's my function there, and I decide that I want to figure out what's the average rate of change of this. So we're really just looking at this little section right here. Well, what's the average rate of change of that? Because you can kind of see that from here to here is kind of a positive rate of change. It's going up, but then it turns around and comes down. So it averages out and it seems to be more negative overall. Okay. So the idea is that we take what's called a secant line. Secant line is a line that's drawn through 2 points of a curve. So we cross through those spots right there. So what we're doing is we're finding the slope of those 2 points. Same thing as you've done before. The slope of my secant line is just y2 minus y1 over x2 minus x1. Down a little bit. Clean that up a little bit. So x2 minus x1. Okay. So that's what we're finding. So when I give you a problem like this one, find the average rate of change of f of x equals negative 2x squared plus 4x plus 6. And we're going to find it on the interval -3 to -1. So these are my x values. This is my x1 to x2 range. Okay. What we need to find, if without the graph, we're going to find it algebraically, find the y values that go along with those points. So first thing I'm going to do is what's f of -3? So it's going to be -2 times -3 squared plus 4 times -3 plus 6. Okay, so plug that in my calculator here, I end up with -24. Do the same exact thing for f of -1. So -2 times -1 squared plus 4 times a -1 plus 6. So we get 0 now. These are actually points that are on the curve. This is going to be the point -3, -24. And this is going to be the point -1, 0. The next goal is I want to find my average rate of change. Let's go ahead and plug that into the slope formula. So my slope is going to be, we can do y2, which is 0, minus a -24, and then -1 minus a -3. Okay, so we did subtracting negatives, we'll just make those positive. So we get a positive 24 over a positive 2. So my slope here is going to be 12. Okay, step 1 is done. I found my average rate of change. It's 12. Now for the equation, the secant line, I've got my slope. I've got a point on the graph, like I'll pick this one right here. I'm going to start with point slope formula. So that's going to be y minus my y value. So it's going to be y minus 0 because of my slope times x minus a -1. So those will turn into a positive 1. Now I can go ahead and distribute this. I can turn it into slope intercept form. So this will simplify to y. 12 times x is 12x, and 12 times 1 is 12. So that's my secant line here. Okay. This is just a rough sketch of it. This is actually the wrong curve. Secant line is the same slope, but it's the wrong setup on that one. Okay. So this is the curve, like this image is not quite right on that one, but the idea is the same. This is kind of like the secant line. We would pass through 2 points on there, and we found the slope and the equation for that line. So let's talk about a word problem. Suppose the height of an object to drop from the roof of a 50-foot building is given by h of t equals -16t squared plus 50, where t is the time in seconds after the object is thrown. Find and interpret the average speed of the object for the time interval 0.5 seconds to 1 second. So here's my two x values. We'll call it x1 and x2. So the first thing I need to do is I need to find h of 0.5 and h of 1. So this is going to be -16 times 0.5 squared. And h of 0.5 is going to come out as 46. Here I'm going to have h of 1 is going to be -16 times 1 squared. Oh, I forgot to do plus 50 up here. My bad. And then plus 50. So h of 1 is going to come out as 34. Okay, so now I can go ahead and do my slope formula here. So I'm just going to do it as I can do 46 minus 34 over 0.5 minus 1. That's going to give me 12 over a -0.5, which when I divide that out comes out to a -24. Now, the negative value just tells us that the object is going down. That's all it is, a little physics concept. The actual speed we're talking about is just going to be 24 feet per second. Okay, so remember we're using our units here. It's dropping for t is time in seconds, and the height was starting with 50 feet. So we're doing feet per second here. Okay, and that's just a confirmation there. So find the average rates of change for this function on the interval 2 to 5. So same thing as before, we're going to do f of 2 is going to be negative 2 times 2 squared plus 4 times 2 plus 6. If I do that, I'm going to get f of 2 comes out as 6. And then I'm going to do the same thing with f of 5. So it's going to be negative 2 times 5 squared plus 4 times 5 plus 6. So f of 5 comes out as negative 24. So again, this is representing 2 points on the graph. 2, 6, 5, negative 24. So to find the average rate of change, I'm just going to go ahead and do the slopes of those. So negative 24 minus 6 over 5 minus 2. So that's going to give me a negative 30 over 3. So my slope is going to be a negative 10. And again, visually, this is what it kind of looks like right here. So 2 went up to, what was it, 2 comma 6 and 5 negative 24. It's a little bit off again on that one, but close enough. Okay, and there's that secant line that passes through. All right, I think last example here. Formula for the distance traveled by falling objects on the moon is d of t equals 2.7 t squared, where d of t is the distance in feet and t is the time in seconds. We want to find and interpret the average speed of an object for the time interval of 1 to 2 seconds. So same thing as before, we're going to find d of 1 and find d of 2. So it's going to be 2.7 times 1 squared and 2.7 times 2 squared. Okay, so d of 1 is just going to come out as 2.7. And d of 2 is going to come out as 10.8. Okay, so that means my slope is going to be, I can do 10.8 minus 2.7. Oops. Okay, and that'll be over 2 minus 1. Okay, so I do that, and I'm going to get 8.1 over 1. So what that means is for my average rate of change, it is 8.1 feet per second. Okay, and that's going to be right there. Same thing. Again, so because we're using the units on here, we're traveling a certain amount of distance in that time, we're doing that distance feet over seconds here. And that is it for today. That's our average speed or average rate of change when we talk about these intervals. Okay, that's it for 1.4-2. So check back on that later. Take care.